Hello viewers, welcome to my channel and welcome to class once again. In this video I want to quickly show everyone on how to compute for the linear accuracy for their traverse survey. So please, if you are just joining us for the first time, do well to check under this video description to see the previous classes we had on traverse computation, so that the data we are having on this sheet is not going to be strange to you. Okay, so we just want to quickly check the level of accuracy for this traverse survey. Primarily, the linear accuracy helps us to check if our survey has met the required standard of specifications. And we are aware that we have the first order, second order, and third order surveys. So without computing for the linear accuracy, it will be very difficult or almost impossible to know which of the order of surveys has our job met. So that is why we are here. So if you check what is here, we are having a forward computation sheet, and the data or the values we are going to be using is the misclosure in nothings and the misclosure in instance. All right, disregarding the signs. So the misclosure in nothings and misclosure in instance is the parameters we are going to be needing to compute for the linear accuracy. Okay, so this can actually be computed when you sum all the values of your data nothings, all right, regarding the sign and not disregarding the sign. So when you sum your data nothings values, you are going to be having your error. Then at the nothings as well, you are going to sum it up. Okay, you are going to sum those values, then you are going to be having a value beneath, which is the summation of data nothings. So this value is expected to tally with the misclosure in nothings and the misclosure in instance. So if you check this table, you see that I have nothings here, then double column, then I have instance. So these are just nothings and instance coordinate values. All right, so please check under the video description to understand how we came about all this. So I'll just be using these values, the misclosure in nothings and the misclosure in instance, which is 0.016 and 0.007 respectively. So to compute for our linear accuracy, all I have to do is to use this standard formula here. Linear accuracy equals 1 all over sum square of misclosure in nothings plus misclosure in instance divided by total observed distances. Okay, so this is the standard formula, and it can also be written this way: 1 ratio total observed distance over sum square misclosure in nothings plus misclosure in instance. So this is the standard formula that we are going to be using. Okay, so to substitute for our values, remember where delta n is the misclosure in nothings and delta e is the misclosure in instance, just like what I showed you all earlier. The misclosure in nothings is 0.016, then misclosure in instance is 0.007. all right, so these two parameters is what we are going to be substituting at this formula here. Okay, why the total observed distance is the values we have as the summation of our total observed distance on this column is what we are going to be substituting here. Okay, so let's just go straight to that. So I'll be using this calculator here, FS991ES Plus. Okay, so this calculator is what is best recommended for. I'll be recommending the same to everyone who are geomatic students out there, so you can get this calculator. It is actually beautiful. So we are just going to sum all our observed distances on this column, all right, starting from the first to the last. Okay, so by using this calculator, does this way. So I have 21.300 then 21.300 plus the next one 32.700 plus the next one 20.180 plus the last one 32.680. So I'll just press the equal sign. Then I'm having it in fraction, so to have it on decimal I'll press the SD sign. So what I'm having is 106.86 as my total observed distances, that is the summation of all distances. Okay guys, that has been substituted as my summation of all observed distances, 106.68, then over square root of some square of my misclosure in northings, then misclosure in eastings, just like what I have at my table. Okay, so all I have to do is now to solving and computing for my denominator, which is the square root of some square of my misclosure in northings and eastings, by just punching it this way quickly. So I will click on the square root sign on my calculator, then the bracket sign, then input my value 0.016, then close the bracket. Okay, then use the square sign plus, do the same thing for the misclosure in eastings, then close the bracket, then square. Alright, so this is how to punch the denominator. Okay, then you are going to press equals to on your calculator. So here below I am having 0.0175. okay, 0.0175, so I'm going to approximate to that extent, then substitute the value inside my formula. So guys, as you can see, I have just input the value and substitute it respectively. So the next thing is just to punch the final answer. So what I'll be punching is 106.68 divided by 0.0175. So to just do that, it's just easy to. So you use the fraction sign here, punch that, then you insert the values respectively, 106.68, then at the denominator I'm having 0.0175, then press the equal sign. So here I am having 6096. all right, so I'll just write down the value. So I'm having 6096. So here all I have to do is to approximate this value to a whole number. So I'm having 1:6000. So this is to a whole value. So this can also be written as 1/6000. So what this simply means is that our linear accuracy for this computation, this traverse job, is 1 to 6000. Do we get that? So remember, from our basic understanding in traversing, in solving, we are actually told that first order job, for the first order survey, the accuracy is 1 to 20,000. While for the second order, the accuracy is 1 to 10,000. Then for the third order survey, the accuracy is 1 to 5,000. So if you have done this and you find out that your level of accuracy is less than 1 to 5,000, that simply means your traverse survey has not met the required standard for the third order survey. Alright, so guys, if you've computed for your linear accuracy and what you are vying for or looking for is for your job to be a second order accuracy job, you are expected to be having a linear accuracy that is higher than 1 to 10,000 or equals to 1 to 10,000. Alright, But if your survey is a survey for the third order, all right, your linear accuracy is expected to be equals to this or more than this, which is 1 to 5,000. So you can see that our linear accuracy met the required standard of accuracy for our traverse survey in the course of this video. So guys, that is all in the course of this video. Please do well to hit on the subscribe icon if you find this video helpful and educative enough. Thank you for watching. See you again.